Hello and welcome again to Cambridge Advanced Level Mathematics. Here, the channel that prepares students for their Cambridge Advanced Level Mathematics examinations. Today's lesson, we are dealing with problem 5 taken from paper 1 of 2023. And the question reads as follows. The figure shows the curve whose parametric equations are y is equal to 2t minus 3 divided by 2t plus 3. X is equal to ln 2t plus 3. It goes on to say the curve intersects the y and the x-axis at the point A and B respectively. Let me just repeat what I said. What we have here is a curve, the one that I have drawn in blue, passing through these 2 points A and B. The curve is represented parametrically, and y is equal to 2t minus 3 divided by 2t plus 3, x is equal to ln 2t plus 3. The first question says, find the y dx. Second question, find the gradient at the point A. Third question, find the gradient at point B. Notice y here is not given explicitly or expressed explicitly as a function of x. Otherwise, we would just be able to find the y dx using one of the methods, your product rule, your quotient rule, your implicit or whatever it is. But here, the two equations are expressed parametrically and are related to each other through the parameter t. And so we have to proceed as follows before we can get to our dy dx. The first thing that we have to do is to find the rate at which x changes with t. In other words, we want our dx dt. Okay, we have our dx dt. But how do we get our dx dt? Because if you look here, x is actually a function of a function, because ln itself is a function, and what is inside the brackets is a function of t. So ln x is equal to ln t is a function of a function. And so to get dx dt, we have to go through the chain rule. We must go through the chain rule. Okay? Then we will have to find dy dx. We need our dy dx. How do we get dy dx? This is a quotient, and so we need the quotient rule. Quotient rule. Okay. Now, when we have found our dx dt and our dy dt, we then combine those two results to get our dy dx. But how do we get our dy dx? We use parametric differentiation. I'll just write diff for short. So first of all, dx dt, chain rule, I wrote x there, sorry, I beg your pardon. dy dt, again, our quotient rule to get our dy dx through parametric differentiation. So let's see how this works in our particular example. Now, we said x is a function of a function. And so therefore, we have to go via this route. Let u equal to 2t plus 3. This would then imply that x is equal to ln u. Okay, so what is du dx? What is du dt? Du dt is equal to just 2. What is dx du? Dx du is equal to 1 over u. What is du? What is dx dt? Now the chain rule says dx dt is equal to dx du dt. Plug the values in. Dx du is equal to 1 over u. Du dt is equal to 2. So this becomes 2 over u, which is equal to 2 over our u is that 2t plus 3. So that is our dx dt. Let's put it somewhere here in a corner because we are going to need it in future. So dx dt is equal to 2 divided by 2t plus 3. Okay, that's a t there. So put it in a nice little box there. There's our result. So let's deal with dy dt. Dy dt. Now we know that y is something over something. So y is equal to 2t minus 3 divided by 2t plus 3. Let this be equal to u over v, where u, of course, is 2t minus 3, and v is 2t plus 3. Now, the quotient rule says dy dx, which of course will be dx, of t, d dt, dy dt, d dt of u over v is equal to v du dt minus u dv dt. All this divided by v squared. That's the quotient rule. Let's plug in the values. What is our v? Our v, of course, is 2t plus 3. So 2t plus 3 in brackets multiplied by du dt. Du dt, there's our u there. It's just 2. Minus our u is 2t minus 3 multiplied by our dv dt, which is just 2 also. All this divided by 2t plus 3 all squared. We can simplify this. This becomes, there is a 4t there. So we have 4t here plus our 6 there. Then we have a minus 4t and a plus 6, minus 3 times 2. All this divided by t plus 2t plus 3 all squared. We can simplify this. 4t minus 4t disappears. 6 plus 6 gives us a 12. So we finally have 12 divided by 2t plus 3 all squared. Let's put the result in the same corner up there. So our dy dt is equal to 12 divided by 2t plus 3 all squared. Okay, now we are in the parametric differentiation region to get our dy dx. Now, dy dx now, dy dx is given by dy dt all divided by dx dt. Plugging in those values, we have dy dx, of course, is 12 divided by 2t plus 3 all squared. We are dividing by that, so we turn it upside down. It becomes 2t plus 3 on top and 2 there. Cancelling, we have that. We get our 6. This cancels with that and reduces the power to 1. So finally, we have 6 over 2t plus 3. That is our dy dx. There's your dy dx. Look at the route we had to follow. We went through the chain rule to differentiate our x. We went through the quotient rule to differentiate our y. Then we went through parametric differentiation to finally get our dy dx. It's time to go to the next question now. Question B says, find the gradient at A. First of all, we need to put this result somewhere, dy, because we will need it. Dy dx now, it's this value, which is 6 over 2t plus 3. Put it in a nice little box there. Okay. Now we need to find the gradient at the point A. Now what's going on at the point A? A is on the y-axis, and x all the way along the y-axis is known to be 0. So the coordinate of A here, the x-coordinate of A is 0. Of x is 0. So what is x? X is given by that. So we can write, first of all, let's write our x. X is equal to ln, 2t plus 3. But we are given that x at A is equal to 0. So what is t if x is equal to 0? First of all, let's write this in another way. We know that we can write this as x is equal to the logarithm to base e of 2t plus 3. That's the meaning of this. Logarithm to base e of this. But what does this mean? This means that this base e should be raised to this power to give us this number. In other words, base e raised to the power x should equal 2t plus 3. But x here is equal to 0. So what is any number raised to the power 0? It's equal to 1. So we can have e to the power 0 is equal to 2t plus 3, meaning that 2t plus 3 is equal to 1. So what is t? T obviously will be minus 1, because we take our 3 there, it becomes minus 2, then 2t is equal to minus 2, meaning t is equal to minus 1. So t is equal to minus 1. So if t is equal to 1, what is dy dx? So dy dx is given by dy dx is equal to 6 divided by minus 2, because t is minus 1, plus 3. Minus 2 plus 3 is 1. That just gives us 6 there. So the gradient at this point is 6. Next question, find the gradient at the point B. What's going on at point B? B is along the x-axis, so y all along there is equal to 0. But what is y? Y is that. So again, we equate that to 0. We equate y, the function that expresses y, the equation that expresses y as a function of t, we equate it to 0. So we are going to have 2t minus 3 divided by 2t plus 3 is equal to 0. Because we found that y here is equal to 0. Cross multiplying, we just get 0. So we finally have 2t minus 3 is equal to 0, meaning that 2t is equal to 3, t is equal to 3 over 2. Now, if t is equal to 3 over 2, what is dy dx? Well, dy dx will be equal to 6 divided by 2 multiplied by 3 over 2, that value there, plus 3. Well, the 2's cancel out, and you are left with 3 plus 3. So 6 divided by 3 plus 3, which is 6 divided by 6, which is equal to 1. So dy dx here, it's equal to 1. That was the answer to our problem number 5, paper 1, 2023. Till we see you again in our next video. Thank you.